Alright guys, hello and welcome to, I guess you guys can't hear me.
Hello, hello,
Hello, hello, hello,
hello.
hello, hello.
Do something else. What? All right, guys. So today, this is our P4 session, the last P4 session, obviously. So in this, what we are going to be discussing is just some parting tips, because you know that P4 is obviously the easiest paper out of all of these to discuss. So let's go to a clean slate here. All right. So things that I previously told you, obviously those are still very, very important. But just go back there for a moment. Which is all of this stuff, right? So remember how we broke ATPs down into some chunks, and we were talking about how we are going to tackle the ATPs right when we were starting out. So this is still a good reference for you guys, just to double check what you know and what you don't know. So the first thing was just measurements. right? So reading scales of any sort using length measurement instruments, and then I gave you some examples, which included instruments that we've already done and also some new ones. Time measurement, volume measurement, all of this we've talked about. Mass measurement, right? So we use balances for mass measurement. The idea of precision is something that has been discussed time and again in the solving of past papers, which is that, for example, if you are reading a meter rule, and let's say if your length exactly turns out to be 25 centimeters, to show the precision of the instrument, which can take it to one decimal place as well, you would write it as 25.0 centimeter. Then some measurement techniques of measuring the diameter of a wire. This is something which is used. Either you have something like this used where you wound a wire around some sort of a solid, and then you measure the length of end turns of wire. Or sometimes you would also be expected to do this, that if you have a really long, really thin wire, what you can do is you can cut up pieces and then line them up side by side, and then take the end-to-end length and then divide by the number of pieces to get the diameter. Right, so both of these we've talked about. So if we are to measure the diameter of a spherical object, in the case that this is not as small to fit in a micrometer. So for example, if we are to measure the diameter of a basketball, we can't do this using a micrometer. So what we do is we place it on a meter rule, and we have some blocks which basically trap that ball in place. And then once we take off these readings from the meter rule, the difference between them just give us the diameter, right? Thickness of a pipe, it's not really asked all that much now. But the thickness of a pipe can be found if you take the external diameter minus the internal diameter. But that would be both of these. So you divide by 2 to get the thickness here, right? Errors, uncertainties, and improvements, all of this we've done as well. So how you can avoid parallax errors with different instruments. Again, this is something which is asked time and again, and how you place your eye perpendicular to the mark being read. Zero errors asked really sparsely nowadays. Human reaction time, again, do remember that whenever you are talking about any suggestion, any improvement of any sort related to the human reaction time, remember that it can never be completely gotten rid of. It can just be reduced. For example, in the case of the swinging of a pendulum, you know that the human reaction time is the same. So what you do is you make your time interval larger so that the human reaction time becomes a smaller fraction or a smaller proportion of that time, right? And then errors according to context. Again, we've also had ample practice of this. For example, if you are maybe looking at the length of a spring, so you would use a clamped meter rule so that the basically the bouncing of the spring doesn't make it difficult for you to take readings. Averaging, so how averaging also is a way to make your readings more accurate. And the precision of readings according to the context, this we've also talked about to some extent. For example, even if you are using a stopwatch which is accurate to 0.01 seconds, but maybe the examiner can give you this case that you are taking readings correct to 0.5 seconds, even though your instrument is as precise. So maybe there is some problem with the experimental design such that you cannot humanly take very accurate readings beyond 0.5 seconds maybe. Maybe the time interval is too small to measure, which makes that uncertainty in the reading very, very large, right? Experiments and drawings. So obviously you guys should have the list of all the experiments in O-level physics at the back of your head. That will always come in handy in ATPs. In reality, in ATPs, you don't need to know anything by heart beforehand, but it can always come in handy. How to improve accuracy, this we've talked about in some detail. Safety precautions is not in your syllabus most of the time. Sometimes you might be asked a 1 or 2 mark part. We've also gone through this. For example, if you have a falling object, you can say that you can use a sandbox to capture it. Or for example, if you're using a radioactive source, you can say that you should use a lead line box to store and move the source. Right? With any sort of experiment related to heat or electricity, you can say that you wear rubber gloves to replace those components to prevent burns. Always with drawing, do remember that labeling is really, really important. Even if the examiner has labeled something, labeling it again is not going to hurt you, right? So most of the time in ATPs, you do not need to draw diagrams, but sometimes you might have a case where you do need to draw one. Circuit diagrams as well, we've talked about and we've seen in some of the ATPs that we've been doing. Equipment and users, so we went through all of the apparatus which is given in the syllabus and the uses of each instruments. Some of the ones that come to mind are the set square, which can be used to ensure a 90-degree angle. So basically perpendicularity. And spirit level is also something which is used to ensure something is horizontal. We've seen pictures of these as well. Again, whenever you are, for example, doing a planning question, you can assume that everything which is standard to a lab environment is already with you. So you have a measuring cylinder, a pipette, a burette, anything of that sort that you need, you already have, right? So these are just some special apparatus and how they can help you out in different experiments. Drawing graphs, again, we've had a lot of practice of this. When you will be drawing a graph tomorrow, do make sure that even if the examiner says a best fit line, do look at the points and see that whether a line makes sense or not. I think we did discuss this in one of the IGCSE winter 23 papers maybe. So in that clearly the points were going like this, so obviously you can't draw a line. It has to be a curve, right? So sometimes examiner will ask you to use your good sense to judge whether to draw a line or a curve. And the idea of drawing a best fit line is that your points must be evenly distributed about that line. So how many you have above is also approximately, ideally, how many you should have below. Above and below, these points should be the same. And again, with curves also, it's the same idea. Always do label the axes of your graph. So for example, if you're supposed to make a graph, do label whatever this is, along with its appropriate units, right? So do label this. And relationships from the graph, often, for example, if you have a straight line graph, you will be asked to talk about this, that what relationship does this represent? If and only if the graph does go through the origin, you will say direct proportion. Otherwise, you can say that as this y increases, x increases, right? For example, if you have a graph like this, and let's say this is some y, this is some x, you would say that again, as x increases, y also increases, but it's increasing at an increasing rate. For example, if you have a graph like this, then you would say y is increasing at a decreasing rate, right? So some basic stuff that you guys have already used in your paper twos and kinematics. So this is obviously expected of you. Precision of values in the table, this is something you must keep in mind. So for example, if you are taking the average of some time values which are given correct to 2 decimal place, then the average would also be to 2 decimal place, right? And any and every value that you have to calculate, you can also give to 3SF and your examiner will give you marks all the time. Points for calculating the gradient, these must be very far apart, right? And it always helps to draw a triangle like this. Usually it's not required, but if sometimes the examiner does tell you to draw a triangle, then you have to draw a triangle, right? This just helps the examiner see what points you've taken. So readings more or less than a certain value. Anyway, let's go on to the next one. Limits of experimental accuracy. This we've also done in a lot of detail. That how do you check whether, according to your experimental procedure, whether two values are equal or not. So you say that they should be within 10% of each other. Planning questions. Again, you know that planning questions, it's really easy. In my opinion, the easiest part on ATPs. What you want to vary, what do you want to measure, and to ensure a fair test, what is kept constant. If you just talk about these values and these variables properly, you already have half the marks in the bag. Then it always also helps to say that you should do this for 6 number of readings. But again, when you are writing your planning question, you will not just say, I'll take 6 readings. You will give your answer according to the context. So, for example, I remember that one of these questions that we were doing was where we were testing different thicknesses of insulation to see what affects the cooling, the rate of cooling. In that case, what I would say is that you use 6 different thicknesses of that insulating material, right? So just make it slightly according to the context. And then how to conduct the experiment, you know that this is usually given in your paper. We don't really have to talk a lot about it. Sometimes we do, but most of the time we do not, right? Then drawing a table with the table serial number is optional. If you don't like this, you can totally leave this out. And then the everything that you need, usually you don't even need this large of a table. You need one value and another value, and sometimes you need a third value. So just make sure that your symbols are proper and you put in a slash and after that write the unit, right? And then again, last part, which you can always say is that to test this relationship, you plot a graph of whatever things you're investigating, and that's how you draw conclusions. All right. So this is some stuff about it. Now, sort of like a guess from my side is some things that just come to mind when I'm thinking about ATPs is you have a lot of those pins experiments in light. Now, if you guys remember when we were doing this in theory, I made you guys write down those experiments. Oftentimes, you'll be asked to give improvements regarding those, that how can you make this experiment more accurate? So you can always say some of these. So you can say align and view the bases of the pins, right? So that's how you align those pins. You can also say this, that place the pins as far as possible. And for drawing the rays, you can always say that use a sharp pencil to draw. Right, so these are just some things that come to mind. Apart from this, again, this is not really asked in a planning experiment, but sometimes the examiner may give you an electricity experiment, maybe in like question number 3 of your ATP paper. So again, just some sort of, precautions or just some things that can make your experiment a bit more safer, a bit more accurate. So now we're talking about electricity experiments. So you can always say switch off circuit between readings. Or you can also sometimes, if you have an experiment which uses crocodile clips, you can say clean the contact of clips using a wire wool. So wire wool is basically what you guys have at home to wash dishes, right? So that's known as a wire wool. So yes, some things about electricity that you can talk about. Yeah, so that's what comes to mind. So these are some of these questions that we were looking at when doing some topical practice before going on to the yearly ones. So some things like these that you just have to think about on the spot. So for example, here the examiner was asking, how do you find the density of these glass beads, right? So obviously one glass bead is very small to measure, and also it's irregular. So I don't even know if it's a circle or not. So how do you find the density? Is that I throw all of these into a beaker of water and I note the increase in volume. And similarly, for example, if I'm talking about density, so then I place all of them on a balance, I get the masses, and then I just use density equals mass over volume. All right. So this was the question we did on sort of like kinematics. Again, you have the suggest parts here as well, which is something that you need to think about. So for example, suggest a reason why the value for T average that we calculated is not more than 2 dp. So the answer to this is that your raw values also do 2 dp, right? Why is the distance chosen to be as large as possible? Again, so if the distance is large, the time would also be large, so that minimizes the effect of human reaction. Then I think here we made this graph and we talked about the line of best fit, how we draw that. So if you look here, it's making me dizzy. I think this line has shifted a bit. Probably it would be supposed to be something like this, maybe. But I'm looking for an even spread, so maybe. Yeah, so probably something like this. Again, questions like these are not asked all that often. Again, when extended, the line of best fit does not go through the origin 0, 0. Explain why. So in this case, you need to think about what going through 0, 0 means. Because you plotted a graph of A versus T, right? That's what you did. So that means that even if you have something which has no area whatsoever, if you drop that, it's still going to take some time. So you just need to use some common sense according to the context provided to you. Then these were those pins experiments. Again, this is some precautions that we've talked about. Again, for the light experiments, I honestly don't find them really hard because with the basis of the pins, with the pins, there are some improvements that you can write, and it's always going to be that. Apart from this, as long as you're following the steps, you will get the mark. But something which is important here, and I've talked about this previously as well, is to not let yourself get phased by things that you know to be true in theory. For example, in this case, the mark scheme explicitly was giving this answer in the mark scheme as the angle of incidence being 40 degrees and the angle of reflection being 42 degrees. Now, if somebody is trying to be extra smart and if he's doing this question, maybe he'll try to tweak the values and make them both meet at 41 degrees. This is wrong, right? The examiner wants to see whether you are going to fabricate your readings or not. So you just need to be very honest when doing these experiments. You just need to not let the knowledge of theory that you have basically mislead you in this case. Then we've also talked about this one where this was actually a planning question, sort of like a planning question because this was 2015. It's definitely more technical than the planning questions we think about. So yeah, that's how we were supposed to do this one. Measuring speed of sound, again, with sound experiments, you can always say use an open space and we are so far away from all buildings and a open quiet space. So yeah, that's some things that you do. Again, also sometimes these suggest parts might have reasons that you might think are somewhat non-technical, but sometimes the examiner is willing to give marks for these. For example, in this one, why two other students did not manage to obtain a suitable reading. So it could be very simple that they're not paying attention, that sort of stuff. So it seems like really stupid to write, but again, you never know. Just don't leave it empty. Do write down something that makes some sense. Probably the examiner will give you some credit about it. So R equals V over I, this we've also done. And then this one, I guess, was the last one that we did, which was basically a ATP question regarding radioactivity. So we try to touch all of these chapters, all of these, all of these chapters and all of their ATPs, right? So yeah, that's about it. If you guys have any questions, anything you want to ask, go ahead and shoot. That's what comes to mind for me. If you guys have any problems or something. All right, so with the planning question, look, guys, you just have to talk about a few things. Let me just show you here. Whatever variable you change is the independent variable. All right. Whatever you measure is the dependent variable. So for example, if I, again, let's just show you a question. This may be getting a bit difficult to talk about without having a question in front. For example, if you look at this one, I think this is one of the most recent ones that we did. So the student investigates the time taken for the water to evaporate due to dryness when heated from above. 4.1 shows the setup power of the heater is constant. The following is also available: supply of water at room temperature, meter rule, infrared heater, everything which is shown. Plan an experiment to investigate how one factor affects the time taken for the water to evaporate. Now, if you just think about it, you can probably see that you are going to measure the time. And to investigate that one factor, you are going to change that factor in some way. Now, if I remember correctly, then in this case, what we changed was the distance of the heater from the water, right? So that's what we did. Something else that you could also do is, for example, you can see how the volume of the water affects the time it takes for the water to evaporate, right? So what you want to change, that's independent. What changes as a result, that's a dependent variable. All right. Let's see if we can also have a look at some other questions that we've done. What's this? Again, with volume reading, do remember this basic stuff like reading the bottom of the meniscus and whatnot. Mhm. Now, for example, this one. Plan an experiment to investigate the change in resistance of the lamp filament when the current is increased. So obviously here, the current is what you are changing. That's the independent variable. So you say, I'll vary this or I'll change this, and you'll measure the resistance, right? That's what we talk about in this entire question. So in this case, this was one of those variables where you didn't really have to keep anything constant. And again, before sort of going ballistic over it, trying to think of what to keep constant here. Also, do look here that in this in these bullet points, you don't have anything suggested as to what you should keep constant. In all other questions, this was suggested what you need to keep constant. So sometimes, very rarely, there could be a case where there are no marks for saying this. Right, so just look out for that as well. Yeah, so That's what I have to say for this. Let's see if we can, all right, let's see if we can pick up sort of like another ATP, just so we guys see what we know. At random, any ATP, we just need to see how much we know. And this one we've done. Oh, this is summer 23. No, I don't need summer 23. All right, let's have a look at this one. So this is summer 16 paper 41, again, a totally unrelated paper. I just want to show you guys how older papers look like, and I just want to give you a little bit of boost of confidence to see how this is going to work. All right. So a student makes an electromagnet by wrapping a length of wire around a piece of soft iron and connects it into a circuit as shown. He closes the switch and finds out the maximum number of paper clips that stay on one end of the soft iron. All right. And then it says part A suggests two changes to the apparatus that increase the current. Right? So how can we increase the current here? Well, one of these is very obvious, right? You just reduce the resistance of the variable resistor. What else could you do? How do you increase the voltage? If you look here, this is a cell. You are in the right direction, but how do you increase the voltage? Because it doesn't have like a knob or something that you can just rotate to increase the voltage, right? You can say you can put another 1.5 volt cell in series with it, right? That basically adds up to the EMF. So you can say something like that. Part B, so he does this for different currents, and he sees when the most paper clips basically stick to the electromagnet. And in this, so in the space below, draw a table to show the results of this experiment. Right. So to show the results of this experiment, again, what you would just do is you would make a table of the current and how many paper clips are sticking. Right. So that's what this is. Part 2, a student makes a pendulum using paper clips. He joins 14 identical paper clips together end to end. He suspends them vertically from a pin attached securely to a bench. He moves the bottom paper clips to the side and releases it. The paper clip swings freely from side to side, and then he measures the time taken for 10 complete swings. Right, finding the average not very difficult. But again, this was for 10 oscillations. So for one swing, you would just divide by 10. Pretty straightforward. Part 3. The student has a reaction time of about 0.2 seconds. Explain why the student measures the time for 10 swings rather than the time for one swing. Again, if you just write words without explaining what it means or how or what's the benefit of doing that, you won't get any marks here. If you just say human reaction time without mentioning that how this why the student does this, what does it do to the accuracy, right? If you don't say this, you will not get the mark. So here what you would say is because the time for 10 strings would be more, so that human reaction time, that 0.2 seconds here, would be a fraction of a larger value, right? So it reduces the impact of the human reaction time. Again, complete the table, draw the relationship. Now, in this case, for example, if you look here, the examiner does say draw a smooth curve of best fit, right? So however this curve is, if I just look at these values, so I hope you guys can see that as n is increasing, t is increasing, but not very fast, right? N is always increasing by 2. Initially 0.38 to 0.58, this is a jump of 0.2, but then those jumps are getting smaller. So to describe the relationship between t and n, I would say that t increases as n increases, but at a decreasing rate, right? Then estimation, you just do, what do you call it? You read off from the graph. So just one effect of using paper clips that are not identical. So in this case, the examiner did use identical paper clips, right? What if you have paper clips which are not identical? What's going to happen now? Again, this is a suggest part. You need to just think a bit about this. If paper clips are not identical, let's say if you have a really heavy paper clip in the middle versus lighter ones towards the end, would it complete proper oscillations? The answer is no. So if you just explain this in some way, the examiner will give you the mark here, right? Mass, so this is volume and density experiments. And this sort of an experiment, what is better at emitting infrared radiation? So again, this is also an experiment we've done, but it's really highly unlikely that you'll get a question like this on your paper. Let's have a look at something else. Just because we have the time. All right, yeah. So that reminds me. Do also look at the improvements for questions related to lens. I know we did a recent one where we say that the lens and the screen must be perpendicular to one another. They must all be on the same horizontal level. So do go through those as well. So yeah, do keep that in mind. Again, at this stage, I wouldn't really recommend you to solve a lot of papers. If you just look at some questions, and if you feel like you don't know the answer to that, just go to the examiner report, not the mark scheme, and just see what the examiner has to say about it. So again, distance between object and screen is given. So this time the distance between the object and the screen is fixed. So what adjustment do you make to obtain a sharply focused image? Is now this time out, you just move the, again, it's between the object and the screen, right? So, yeah, so you just move your lens along and see when you have a clear, sharp, focused image forming on the screen. So the focused image is at the top of the screen, right? So this image is forming at the top. Describe one adjustment that the student makes to move the image to the center. So if you want to move the image to the center of the screen, if you just look here, again, I can't draw this right now, but if the object is at a height, if you somehow get the object lower, so it's going to be on the center. Or if you somehow elevate the screen, that's going to be the solution to your problem. The lens is in a holder on a stand. Position of the center of the lens is to be marked. So again, we've also looked at questions regarding this. For example, if this is a converging lens, which is shaped like this, so we take both of these ends of the readings and we really average them out to get the center. right? Then you have all of these calculations which the examiner makes you do, and you had a straight line of best fit here. All of this. This one is on magnetism, electromagnetism. Again, if you know theory in this part, this does help you out. How to increase the current in the wire. The current is to be varied and measured. Draw the circuit diagram of the circuit used to provide the current. Include a method to vary and measure the current. Again, varying the current, the first thing that comes to mind is a variable resistor, right? Describe how to reverse the direction of the current. So you just switch around those cell terminals. How to reverse the direction of the field. Yeah, so you just switch around the poles of the magnet. So you see, once you get a feel of this, it's not really all that hard. And this is the ATP question that we were just looking at. All right. So that's it from my side. Do remember what I taught you here today. And also remember that now at this point, it's not really useful to do a lot of practice. I mean, you guys should just be going through papers and thinking about parts you could not answer. Think about those for 2 or 3 minutes. And if you don't still get an answer, just go to the examiner report to see what the examiner has to say, right? So best of luck, guys. All of us are rooting for you. I know some people may have had a paper two, which was not very well, but again, it's not a problem. Paper four and paper one combined can still outweigh your paper two, right? So do keep that in mind. So yeah, just do your best, and yeah, best of luck for this. So thanks for attending, guys. Then I'll see you inshallah for the MCQs. Bye bye.